Welcome to the EGB120 supplementary video question. Okay, so this question here asks us just to find the value of the output voltage here, VO. Now, so when we're dealing with these op-amp questions, we need to remember our two golden or ideal rules, and that's a really good place to start. So the first one is that the current at the non-inverting terminal equals the current at the inverting terminal, which is 0. So the current going into both of these terminals for an ideal op-amp is 0, and the voltage at the non-inverting and the inverting terminal should be equal. These are our two golden rules for op-amps that are important to remember. The second tip is you normally want to start off these analysis questions by doing Kirchhoff's current law at either depending on the question, at either the inverting terminal or at the non-inverting terminal. So what I'm going to do is I'm just going to draw this circuit here again a bit bigger, and we'll make some notes on it and we can find our output voltage. So 2K resistor coming into my op-amp here, inverting and non-inverting terminals, 5-volt source down to ground, 3K feedback resistor over the top, and we are measuring our output voltage here, VO. Alright, so I'm going to start off by doing Kirchhoff's current law at this node here, and we know Kirchhoff's current law says that current I1 plus I2 plus I3, all the currents from a particular node equal to 0. So when you label your currents, you can either label them all as leaving or all as entering. As long as you are consistent, that's fine. I normally label all my currents as leaving. So we have a current here leaving from this node going to the left, which we might call I1. Current going up and to the right, which we can call I2. And then we have this current going into the op-amp, which is called I3. So we can add them together. So what do we know about these currents here? Well, if we look at current I1, I have 1 milliamp coming the opposite way to what we've labeled I1. So I can say I1 is negative 1 milliamp. Plus, we've got current I2 coming up and to the right. So when we're calculating this, what we need to do is look at the voltage potential of the node that we start at. I'm going to call this node VN, N for inverting, or N for a negative terminal. And then we subtract the node that we end up at. So this potential here is our output voltage, so Vn minus Vo, and then we divide by the resistance of the branch that we're looking at here, which is 3K. So that's the voltage that's flowing through that I2 part of our expression, plus I3. We know our golden rule says that IP equals IN equals 0, so there should be no current flowing into that non-inverting terminal. So that's just going to be 0 equals 0. So we've used our first golden rule up here, check. Sometimes we can use this second one here as well. We can say that Vn is equal to Vp because of our golden rule for op amps, and we can see that Vp, the positive terminal, is connected to that 5 volt source, so Vn equals Vp equals 5 volts. So we can sub that into our equation from above, so we have 1 milliamp plus Vn, which is Vp, is now going to be substituted as 5, minus Vo on R, where R we can also substitute in as 3K, is 0. Rearranging this equation to solve for us, we know that the goal in the end is to solve for V out. Rearranging again, multiply everything by 1000 to bring that denominator up. 5 minus Vo equals 3, or solving for V out, we can get 2 volts as our final result.